Hello everyone. I promised a video for you all to take you through some of this AQA assembly language programming, and possibly the easiest way to think about it is because you all seem to be getting on okay with the Raptor. We're going to convert some simple Raptor programs into assembly language, taking sort of the different concepts of the assembly language as we go along. If you click in the assembly language program for AQA, the info button, you'll get this help here. Now we're going to refer to that from time to time. So if I were you, I would do that and have another tab like I've got up here. I've got lots of tabs up here. I'm just going to close those down because they might be confusing to us. Okay, so we've got two tabs. One is a simulator and the other one is the help for that. And I've got Raptor here on this side. And obviously the simplest Raptor command is an assignment statement. So let's do something like that. So I've got ink mode turned on. Let's turn my ink mode off. So if I input an assignment here, and I'm going to have a variable. Now, typically you would have nicely named variables in a Raptor program or a high-level programming language. But the equivalent to having variables in assembly is one of two things. One is either using a piece of memory and loading it into a register, or we can use the registers directly. And you'll notice that in LMC, Little Man Computer, we only had really one register, which is called the accumulator. But now suddenly we've got more. We've got more registers. We've got 13 registers here, R0 up to R12. So that enables us to use these registers as sort of variables, if you like. So let's start off with a variable. So in Raptor, and let's say we're going to say let R0, hopefully we can have variables called R0, and we're going to set that as to have a value of 1. Okay, and it asks us to save. So let's save this Raptor diagram. Come on, go a bit faster. Probably got too many things open at the moment in the background. Come on. Might close down. Let me just close down this. Sorry about this. Not responding. Close down Excel. Something funny going on here. Close down PyCharm. Can't do that. Oh, why did this happen? Let's exit that. Don't save that. Okay, back here again. Hopefully. We'll just restart Raptor. So let's do our assignment again. So we're going to assign this variable called R0, and we're going to assign it the value 1. Okay, and that's what that would look like here. So I'm just going to zoom in a little bit here so you can see that. We're going to assign R0 the value 1. Now, how do we do that in assembly? Well, there are two things that you can do, and we're going to investigate both of those now. One of them is an LDR command, and the other one is an MOV command. So let's start off with this LDR command. Remember, LD stands for load, and R stands for the register. And so in other words, we're going to load something into the register. Okay, and the register that we're going to load into is going to be this register D. So in our case, register D is not RD, but R0. Okay, so this D is standing for a number, basically R0, R1 up to R12. So we're going to LDR, store it into what we're calling R0, which is this variable here, and we're going to store the memory reference for that. So let's start off with here. So we're going to have LDR, and we're going to store it in R0, comma, notice, so go back to the help, LDR, name of register, comma, and then the memory reference. Now the memory reference is one of two things. It's either another register, or it which is called direct addressing, because it gives you directions as to where to find it, or it's called immediate addressing, which means you've got the value immediately. Now, since this is a value that is immediately available, this 1 here, we're going to use immediate addressing, which you should remember as being #1. So if I submit that program, it tells me that I've got an error. Bad parameter at line 0, LDR. Okay, so let's just go back and see what it says. LDR, RD, space, memory reference. And you think, well, what's going on? I don't get it. Try deleting the space. Basically, this LDR isn't quite what you think it is. Instead, you should be using MOV. So we're going to copy a value specified by operand D. Notice that this memory reference is referring to memory only and not immediate addressing. Operand 2 does enable us to specify either a memory reference or, in other words, using direct referencing, or an immediate address. Okay, and that is what we should use. Therefore, we should use this MOV because we want to use immediate addressing. Okay, so we're going to change that now, not to LDR, but MOV, and let's just check what MOV should look like. It should be MOV moving into this register D, comma, the value of the operand. So this now should work. Okay, so you can see from that, that's worked now. Okay, submit that. You can see that that's worked. So you can see the difference between a memory reference and an operand. Okay, if you want an operand, you've got to use. If you want a memory reference, this needs to be a memory reference rather than operand. So you say, well, where do I use that then? Well, what you could have done previously is you could have moved into value R1, the number 1, and then we could LDR, and we want to move into R0, what's stored in R1. Okay, and that would work because, it's still not working. Let's try this again. We need a space perhaps. Does this sometimes. I do find this strange that this LDR gives me nothing but problems. And I would just stay clear of LDR. It causes problems. So let's just stick with MOV. So we've got our R0 and we're storing this number 1. Okay, let's run our program, see what happens. And incidentally, I will explain on earth all these animations are going on about in our next lesson or in a lesson soon. So we've noticed that we have got our value of 1 stored in our R0, and that's the equivalent of what's going on in here. So how about asking us to save, and this time we crashed last time. Hopefully it won't crash this time. Please don't crash this time. And what's going on? Why is it crashing saving? I don't know why, gents, but I just don't seem to be able to save for some bizarre reason at the moment. Just close down. Lots of things going on in here. No. Okay, I can't save my Raptor stuff at the moment. I don't know why. I may have to restart. Something wrong with it. Never mind, I won't do that for now. We'll just restart our Raptor. I have to restart my computer, I think. Okay, so that's the most simple of things. We're going to use MOV to move our assignments in there. Okay, so the next thing, let's have a think about what we would do for an input. So here we might input something, so we'll say input your age, and we're going to store that into a variable called age typically, but we're going to store that into maybe this value called R1. So R1 is going to store our age. Not a great name for our variable again. Try and avoid that, but for mapping purposes to say how this maps onto here, it's probably easier if we do that. So let's reset that, and we'll come back here, and how do we replicate that? So we're going to do input. Let's go to our help. Now we can see at the bottom here that input is actually an extension, and it looks like this. Input RD, which is the name of the register where we want to store the input, which in this case is R1. It's the equivalent of where it's getting the information and placing it into R1. Comma 2 is basically saying from the keyboard. Okay, as you can see here, it says input is basically this comma number represents different devices on the computer. So we've got an input device, which is a keyboard. We've got an output device, which is the screen, which is comma 4 for output. And there might be other ones, because you can maybe have, let's say, a light sensor, and that might be a different input device. It might be a different device attached to your computer. So that's how assembly would sort of list these different devices, or it might be a microphone or something like that. But we're really only interested in the keyboard input, comma 2, and the screen output, comma 4. So go back here. So we're going to input IMP, and we're going to store it in R1, and we do comma 2, which means from the keyboard. Okay. So if we run that, whatever is input will get stored into the memory location R1. Let's do the same thing down here. Let's assemble that and then run. So it's now asking for our input. So if we type in the number 8, we're expecting 8 to go into R1, and there it is here. 8 is now in R1. Okay. So that's inputs. Outputs are very similar. Maybe we want to output to the screen. This is our output. This is device number 4. So if we reset this again, I'm going to output that. So what does output look like? Let's go back to output, and output whatever is in RD and comma 4. So we want to output whatever is in this case R1, and we're going to output that to the screen, comma 4. And we're going to run that to see what happens. And we're expecting to see whatever number I type in here, we're expecting to come out into the output, because that's what it's doing. We're storing it into R1, and we're taking whatever is in R1 and outputting it into 4. So if I type 9, I'm expecting 9 to come down here and get output. There we go. Okay. Okay. Notice it's saying illegal here. The reason being is you should always have a halt instruction at the end. Okay, so hopefully this time we won't get an illegal instruction. So let's run again. I'll type in my 9 in here. Outputs, and I'm hoping I'm not going to get an illegal instruction this time. Off we go. Halt. Okay, it's halted. That's nice. Not an illegal instruction this time. Try and remember to put halts in your program. And your exam board will expect you to remember to do halts appropriately. Okay, so that's assignments and inputs and outputs. That's straightforward. Let's have a look at selection now. So let's just delete this. Oh, don't ask me to save. Oh, it's going to crash again. No, run away. Okay, I'm just going to close the program and open it again for looking at, I don't know why that is. Let's do a selection. So let's put a simple assignment in here. And let's say we're going to set our R0, which is representing our age, and oh no, sorry, let's do an input instead. That's easier. Let's delete that, and put an input in, and we're going to say input your age, and we're going to store that not in the variable age as we did before, but R0. Okay. I know we did it in R1 over here. Then we'll just keep it the same, R1. And then what we're going to do is, depending on what that is, we are going to output a message. So in this simple Raptor diagram, we're going to say, is age greater than or equal to 18? Age is greater than or equal to 18. I'm going to output the message, you're an adult. Okay. And if it's not, I'm going to output the message, a child. Okay, so we've got a really simple Raptor program here. How do we implement this? Well, first things first, I'm not interested in the fact of what it says in the output. Okay, so I'm going to output, I can only really output numbers. It can only store numbers in here. So I'm going to output a 1 for an adult. So let's just change this to being a 1, meaning true, if you like. Age is greater than or equal to 18, true, so you're an adult. Adult means yes, is 1. And child, I'm going to put 0. Output 0 and output, I'll just do it as an integer like that. Okay. Oh, that should have been a 1. Sorry, 1. Okay. How do I do that? Well, let's go over to our thing. So here we have got our input, R1. That's our age. And now we need to look at this. Age greater than or equal to 18. In other words, R1 is greater than or equal to 18. So in fact, I should have typed R1 in here. I don't have a variable called age. It's just a good habit that I've got into is naming the variables properly. So it should be R1 greater than or equal to 18. So this is a selection. How do I do a selection in here? Well, we do that with something called branching. Okay. This is a branch. We either branch down here to this instruction, or we branch this way to this instruction. So let's have a look. How do we do branching? So if we go back to our help and scroll up, we've got this idea of having labels and branches. Labels and branches. Okay. What do I mean by labels? Well, first of all, so a label is something to say, I want you to go to this part of the program. Here, this line coming out of our predicate, which means a Boolean expression inside this decision, it automatically comes down this line and goes to here. In assembly programming, I can't say walk along the line and go here. Instead, I'm going to have a label. So I'll create a label and I'll call the label adult. In other words, part of a code called adult. And if I do that, I want to output to and remember what does output look like? Go back here. That goes output, the value held in RD. So what should we do? Let's store. Let's move into R9, the number 0, and we're going to move R8, the number 1. In other words, this is basically our false, and this is basically our true. Okay. So if we are an adult, we're going to output our value of true, which we're saying is R8. Put R8, comma, and then we're output to the screen. Okay, so output R8, which is going to be a 1. So that's what we're going to do. We're going to say input this value R1, and we want to branch to being an adult. But we only want to do that in the following way. So let's have a look at what we mean by branching. So by branching, we need a condition attached to it. Okay, so we branch with this condition to this label. Okay, so branch, condition, label. Okay, and what are the conditions that we can have? Well, the conditions, as it says here, are possible values are equal to, not equal to, greater than, or less than. Okay, so we're going to say, in this case, we're going to branch according to this value R1. So we're going to say branch R1, so back again, condition, so branch, not R1, branch greater than, that was one of them, wasn't it? Let's have a look. Branch greater than, yes, here we go. So we're going to branch, if it's greater than the value 18, it's going to go to the label. No, sorry, branch greater than, and the greater than possible value condition.